One common challenge for students who want to study the electronic configuration of an atom or an ion is how to fill the orbitals with electrons in an correct order, especially when Hund's rule applies. Here we illustrate the case of silver and silver cation, which can be a very instructional example. Each shell has its own number of orbitals. The first shell only has one orbital, that is 1s. The second shell has two orbitals, which are 2s and 2p. The third shell has three orbitals in total, which are 3s, 3p and 3d. The fourth shell has four orbitals, which are 4s, 4p, 4d, and 4f. The fifth shell has five orbitals, etc. The order of electron filling into the orbitals can be summarized using the diagonal arrows. The first arrow passes through only 1s. The second arrow passes through 2s. The third arrow passes through 2p and 3s. The fourth arrow passes through 3p and 4s. The fifth arrow passes through 3d, 4p and 5s. The sixth arrow passes through 4d, 5p, and 6s, and so on. Therefore, we obtain the electron filling sequence of all the orbitals, which are 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, etc. Each s orbital can accommodate 2 electrons. Each p orbital can accommodate 6 electrons. Each d orbital can accommodate 10 electrons. Each f orbital can accommodate 14 electrons. Now we illustrate how to obtain the electronic configuration of a silver cation. The atom of silver has 47 electrons in total if not ionized. After ionization, the silver atom will lose 1 electron, which gives up to 46 electrons. Our task now is to fill the 46 electrons into the appropriate orbitals outside the silver nucleus. Due to the principle of energy minimization, the first 2 electrons go to the 1s orbital. The next lowest energy orbital is 2s, which can hold up to 2 electrons. Next orbital is 2p, which can hold up to 6 electrons. 2 plus 2 plus 6 equals to 10. We now have already filled 10 electrons into the atom, and we have 36 electrons to be filled. So let's continue. Next we put 2 electrons into the 3s orbital, 6 electrons into 3p orbital, 2 electrons into 4s orbital, 10 electrons into 3d orbital, 6 electrons into 4p orbital, 2 electrons into 5s orbital, and then we will only have 8 electrons left. Let's first put all the 8 electrons into the 4d orbital by sequence. However, this is not done yet. Due to Hund's rule, the electronic configuration will be stable if the outermost orbital is half filled or fully filled. So one thing we can do is to move the 2 5s electrons into the 4d orbital, such that both the 5th shell and the 4th shell can be stable. Therefore, there will be no electrons in the 5s orbital and 10 electrons in the 4th orbital. Let's clean the orbitals that have not been filled with any electrons from our view. The 5s orbital is not filled with any electrons, so let's also clean it from our view. Therefore, the ultimate electronic configuration of silver cation is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 4d10. The outermost orbital is 4d, which is fully filled. Thank you for learning. Like and subscribe if needed.